Continuing with series of videos on HPC and cuda, and today's video is going to be on utilizing multiple GPUs. So far we were using only one GPU to execute a program. Now how to use it? Use two GPUs in a single node using cuda. Now as you can see on the screen, cuda can be used to write parallel cuda program that runs on multiple GPUs on single node. For example, a particular node has two GPUs, then a simple cuda code cannot utilize both of them unless we specifically give the commands to it. That means you have to give one name to one number to one GPU, other number to other GPU, suppose 0 and 1. Now, the idea is in normal vector addition, the pointers are initialized and memory is allocated. So here now to use multiple GPU, we need to use functions like cuda set device 0 or 1. So accordingly it will switch between the GPUs. Now this is a function which we have to use when we use cuda set device 1 or 0 or 1. Accordingly we need to give the cuda map copy command, etc., etc. So let's look at the program. Vector addition on two GPUs. It's like we are trying to add, a number of elements of, let's say we have taken, this is 10 million elements. This is a huge number. And we have done this exercise earlier with one GPU. There also, we have got around 79 microsecond actually GPU execution time. And now let's see how this is going to work actually when we use two GPUs. So the differences in the programming is, see whatever is there in the red, like the pointers you are defining now for different kind of a pointer, you can see that actually. And this is for dimension 2 because we are trying to use two GPUs. Set cuda get device count. It will give you the number of GPUs actually, which in our case it is going to be 2. Now cuda stream, this is a data type _t stream 2, and you have to say cuda device, you have to select 0 or 1. And similarly there are changes like this in every function. Mem copy also there is a slight difference, and here we are using mem copy asynchronous. This is one thing which you have to note actually, and because we are going to use two different GPUs. Now whatever marked in red are to plan for the two GPUs. So ultimately when you run this program, you profile it, you will see that we got almost 83 microsecond, that is the time it took in this particular case. And when we further analyze, we can see that actually practically how it is going to come. Let's see for each CPU. Now here also it says there are two GPUs being used. From here you can see that, and we will practically see that in here. Let us go to the HPC machine and let me connect it to this using the any disk. That means I am connecting into that GPU, and now we are directly into the HPC node. And you can simply run a script called start, and you can show what is the script. Inside the start script, we have put all the commands whatever we have been doing together. Okay, you can quit this program, and now you need to simply run the module load spec. After that you can run this environment. After that you say spec load cuda at the rate 12.4.1. Then you can cut and paste the string of that. Now we're ready to run the program. The program name was multi GPU multi underscore GPU example.c. So this is the program, and we are doing NVCC. This you are going to get here there's an error. This we have come across just now. Let's figure out where it is coming from. Now also we have one more error, that is 45, line 45. So straight away go into that. Unwanted comment line was there, so that is a typing mistake. Now it's running. So you can you run a time command actually to see. There is a command called time also, which can quickly give the time taken, but this may not give a true picture like a profiler. It is saying around 5.2 seconds it is taking, but it doesn't give separately GPU and other details. But we can go to the profiler and try to compare how much is the difference. So this 5.2, it includes everything, the asynchronous communication between the GPU and the CPU, etc. So very unreliable. So that's why we are going into the profiler, and we created a profile like a report 9. And we are running this report 9. Now it says that actually instead of 5.2 millisecond or something, seconds or something, it is taking just 82.7 microsecond only at the kernel level and the GPU. So this is comparable to the earlier, when we were using one GPU, it was taking almost same time, but it may not be the time which we are saving, or maybe resources. So, and many people you have to use the same machine, so large number of people, so it is not good to consume a lot of memory, etc. So you can distribute the programs. That is going to be an advantage. So see you in the next video. Thank you.